Now, finding the intersection point between two lines isn't too difficult if they are presented to you both in the form y equals ax plus b. If they're written in that familiar form, it's not too difficult to find their intersection point, because if y is equal to this and y is also equal to that, then it's fair enough to say that this equals that. Y is equal to them both, so therefore this and that must be equal. So we can start off by saying at the intersection that 2x minus 5 must equal negative 3x plus 10. Now, if we can solve this little equation for x, shuffle it round until x equals something, then we will have found the x coordinate of the intersection point. Now we can do that. Let's move this 5 to the other side. At the moment it's 2x minus 5, so I need to add 5 to this side and also add 5 to this side. Add 5 to this side, I'm just going to be left with 2x. Add 5 to this side, I'm going to have negative 3x plus 15. Now I need to get rid of this 3x from this side. I'm going to move it to the other side by adding 3x onto this side. Minus 3x plus 3x cancels each other out. I'm going to be left with 15. Add 3x onto this side. 2x plus 3 more x is 5x equals 15. Now, if I was to get x by itself, I'm going to need to get rid of this 5. I do that by dividing both sides by 5. Divide this side by 5, I'll have x. Divide this side by 5, I get 15 divided by 5 equals 3. So what I've actually found there is the x coordinate of the intersection point. Once I've found that, what I have to do is substitute it back into one of these two equations. It doesn't matter which one. But if I put it back into either of them, if I put it back in there instead of x, I'll be able to work out what y is. So I can say that when x equals 3, y is equal to, and I'll go back into this equation here because it looks easier to me, y equals 2 times x, that's 2 times x equals 3, minus 5. And 2 3s are 6. 6 take 5 is 1. When x equals 3, y equals 1. So, therefore, the intersection is at the point x equals 3, y equals 1. We normally write coordinates just like that. Let's do another one. They're both in the form y equals ax plus b. So if y equals this and y equals that, it's fair enough to say that at the intersection this and that are equal. At the intersection point, negative 4x plus 6 is equal to 2x minus 12. Okay, solve the equation, shuffle it round until we get x equals something. Start by moving all the numbers to one side and all the letters to the other side. Okay, so we've got this 6 here. If I was to take 6 from both sides of the equation, that would disappear. And I've got to take 6 from this side of the equation, so I'll have minus 12 minus another 6 will be minus 18. Now get rid of this 2x. At the moment it's positive 2x on that side, so if I take away 2x from both sides of the equation, it will disappear from here and I'll just have minus 18, but I've also must take away 2x from this side. Now we've got negative 4x, take away another 2x, will be minus 6x. Now remember that's minus 6 times x, so to get x by itself, I'm going to want to divide this side by minus 6. Also I have to want to divide this side by minus 6. So x equals negative 18 divided by minus 6. That means x equals positive 3. Okay, I've found the x coordinate of the intersection point. To find the y coordinate of the intersection point, all I have to do is get this x value and put it back up in here or in here instead of x, and I'll work out what y is. Doesn't matter which one you put it into. When x equals 3, y equals 2 times 3 minus 12. I'm putting it into the second equation. Just looked a little bit easier to me. 2 3s are 6. 6 minus 12 equals negative 6. That means y equals negative 6. So intersection is at the point x equals 3, y equals negative 6. Now your graphics calculator can do these as well. I think it's good to be able to do them both by hand and on your graphics calculator.